Good morning, all. Welcome to the sessions on transformer. So, in the previous session, we discussed about a full section plan and full elevation of a single phase core type transformer, and we also discussed how to draw the same by using a CAD tool, right? So, but in this session, I have come with a new topic, that is off section plan and off elevation of a three phase core type transformer. Right, that is what today in the session objective is to draw off sectional plan and off elevation of a three phase core type three step transformer. That is what the objective of the session, and for that I have an problem. So in this we need to draw the right off sectional plan and right off elevation of a three phase core type 250 kVA 11 kV 400 volt transformer. So the given details are: cross section of the core, it is 3 stepped. Diameter of the circumcircle, it is given 24 centimeter. So 24 centimeter, if you want you can convert that into millimeter. Center to center distance between adjacent limbs is given 42.5 centimeter. Yoke height 20 centimeter. Total height of transformer is 100 centimeter. LV inner and outer dia is 250 mm and then 283 mm respectively. Here some of the data are given in centimeter and some of the data are given in millimeter, so that it is better to convert the centimeter into millimeter. And also the HV inner and outer dia is 343 mm and 415 mm respectively, and height of the winding is 55 centimeter. These are the given details, and in this our objective is to develop or to draw a right off sectional plan. It is very specific. It is right off sectional plan and then right off elevation of a three phase core type transformer. Now before going to draw this in AutoCAD tool, first we need to prepare a preparatory sketch. So why it is required? The preparatory which gives a detail about all the dimensions of a magnetic circuit and as well as the winding. So that's why before going to draw in AutoCAD tool, it is better to one rough sketch on a notebook. So that is what we do. Okay, now let us draw a preparatory sketch for the given problem, and it is a three phase core type transformer. So let us a three phase magnetic circuit here. So in three phase magnetic circuit we'll be having three limbs, right? We'll be having three limbs and then two windows, and the width of all the limbs are equal in dimensions, right? This is what your three phase magnetic circuit. So in this, the yoke height is given. Here you can see the yoke height is given. This is the yoke height is given, it is 20 centimeter, and the upper yoke is also 20 centimeter, right? And then center to center distance between the limbs, here you can see 42.5 centimeter. So it means this is the center of the limbs. This is the center of the limbs. So it means the distance between the adjacent limbs is 42.5 centimeter. This is 42.5 and then this is 42.5 centimeter, right? And the overall height of the transformer is also given, it is 100 centimeter. Here you can see 100 centimeter. Then what about the height of the window? So the overall height is 100 centimeter and the height of the yoke is 20 plus 20, it is 40 centimeter. Then the remaining is what? It is 60 centimeter, right? Height of the yoke is 20, height of the winding is 60. 60 plus 20, it will become 100 centimeter, right? And now what about the height of the winding? Height of the winding is 55 centimeter. As I already said, the winding will be placed inside the window, right? So it means, so I have window height is 60, height of the winding is 55. 60 minus 55, the remaining is what? 5 centimeter. Sorry, 5 centimeter is, so among this 5 centimeter, 2.5 centimeter and then 2.5 centimeter, it is for insulation between the core and then the winding. So here you will be drawing an LV and then HV winding. Clear? So this is what the thickness of the insulation between the core and the winding is 2.5 and then 2.5 centimeter, and the height of the winding is 55 centimeter. Together it will be 60 centimeter. Clear? Then what about the height of the width of the limbs? So the width of the limbs, it is depend upon the steps. So it is a three-step core type transformer. In the very first session we discussed, if it is a three-step, the step size, it is 90% of the circumcircle dia, 70% of the circumcircle dia, and then 42% of the circumcircle dia. It means we will be having three different steps. That is what three-step core. So let us calculate the larger stamping first. Okay, larger stamping, it is called it is also called as larger stamping. It is 90%. It is nothing but 0.9 of circumcircle dia. What is the circumcircle dia? It is 24 centimeter. So 0.9 times of 24 centimeter, it is 21.6 centimeter, or else 216 millimeter. Clear? So, and the middle stamping is equals to 70%. It means 0.7 times of the circumcircle dia. 0.7 times of circumcircle dia, it is 16.8 centimeter. So in millimeter it will be 168 millimeter. As I already said, it is better to convert all the centimeters into millimeters, right? And the smallest stamping is equals to 42% of the dia. It means 0.42 times of 24 is equals to 10.08 centimeter. That is nothing but 100.8 millimeter. So this is the step size now. 216 mm the larger stamping, 168 mm the middle stamping, and the smallest stamping, it is 108 centimeter. So how it looks actually, the three-step core. So the three-step core means, as we know, this is what your first single step. So this is two-step core, but it is a three-step. So this is your three-step core. So in this, the largest width, this is what the larger stamping, it is nothing but 216 mm, and this is the middle stamping. The width of the middle stamping is 168, and the width of the smallest stamping is 100.8 millimeter. Likewise, from ear to ear is also 216, and from middle to middle it is 168, and the smallest one is 100.8 millimeter. So this is what your preparatory sketch, which gives the details of each and every in the magnetic circuit, and this is what the three-phase core type, and this is the calculation we supposed to calculate the step size depending upon the step core. So now with this preparatory sketch and with this details, we'll draw a section plan and then elevation of a given transformer by using CAD tool. Okay, now I've set the units to millimeter, therefore I should give all the details in millimeter. So it means you need to convert the given dimensions in centimeter to millimeter, right? So first what I want to draw is a section plan, that is what a top view. So for the section plan, what are the data required, or the circumcircle dia, it is 24 centimeter, it means it is 240 millimeter, and I required LV and then HV inner and then outer dia, it is also given. Along with this, we have already calculated the step sizes, three step size. One is 216, 168 and 100.8 millimeters. So first let me draw a circumcircle. So the dia of the circumcircle is 240. So after that, draw an axis line which passes through the center, the horizontal and then vertical axis line. So before converting this into axis line, let me develop or let me draw a core section in one quadrant. Okay, so go for offset here, and here it is asking to specify the distance. So which is the biggest step size? The step size is 216. So 216 divided by 2, it will be the offset distance, and the offset object will be this, and it should be located on one side. Okay, and again, by taking same distance but the object will be the different, now it is horizontal. Okay, escape, again go for offset. What is the second distance? It is 168 divided by 2. Okay, select object. Once you select object and vertical axis, and the other time you will select an horizontal axis. Okay, and then the third one is 100.8 divided by 2 with respect to vertical axis, with respect to horizontal axis. Now you prepared a one quadrant of 3 step first. Okay, so for that go for Control A and then trim. Okay, so you trim all these portions. So now you can see the 3 steps: step 1, step 2, and then step 3. So I am having a 3 steps in one quadrant. Let me select all this and go for mirroring. So for mirroring, let me select the center of the circle. Circle will be the first point. Okay, and by using shift, okay, do you want to erase source object? No. Again you select both, so it will save you the time to trim all the quadrants. Okay, you prepare one quadrant and then go for mirroring, it will be better. You can also drag and then select. This will be the point again. Okay, now this is what your 3-step code. This is the largest stamping, the middle stamping, and the smallest stamping. Now let me convert this into axis lines. Now for that we supposed to load it. So here we have dash and then dot. This is what your axis line. Now I have converted. Now let me draw an LV inner and then LV outer dia. So the LV inner diameter is given, it is 250, and then LV outer dia it is 283, and then HV inner dia is 343, and the HV outer dia is 415 mm. This is what the sectional plan of one limb. Sectional plan of what? One limb. Now I should go for the elevations, right? So for the elevations, what I required? For the elevations I required is what is the yoke height, what is the overall transformer height, what is the winding height, and what is the insulation between the windings and then the core. That is what I required, right? So you can see yoke height is 20 mm and the winding height is 55 mm. So the total window height is 60 mm, right? Because the overall height of the transformer is 100, therefore the height of the window is 60. So among 60, 55 is for the windings and the other 5 mm is for the insulation. But I should have an insulation both at the top and then the bottom. It means 2.5 mm of insulation and then 2.5 mm of insulations. So before that, let me extend this line up to the last circle. Okay, so for that go to extend. It will ask to select the object. It means the reference point. This will be the reference point, and then enter and click on the lines which you want to extend. Okay, right now draw one horizontal line. Okay, so this the length of this horizontal line should be wider than the largest diameter. Okay, and go for offset. What is the yoke height? What is the yoke height? 20 mm, right? So this will be the object, and this is what? 20 mm. Sorry, not 20 mm, it is 20 centimeter. 20 centimeter means it is 200 mm. Okay, this is what yoke height. And what about the insulation between What about the insulation between the core and then the winding at the bottom? It is 2.5 centimeter. It is nothing but 25 mm. Okay, this is the object, 25. Okay, and then again go for offset. What is the winding height? Winding height is 55 centimeter. 55 centimeter is nothing but 550 mm. So from here to here. Okay, and then again go for offset. Again we will be having an insulation at the top also. It is 2.5 centimeter. It is nothing but 25 mm. Okay, and then at last we will be having yoke. The height of the yoke is 20 centimeter. It is nothing but 200 mm. Okay, so now what I want to do is I need to draw an vertical projections where the x-axis cuts the circle except the circumcircle. Okay, now from here I need an vertical projection. Again from this point I want an vertical projection. Again from LV outer, LV inner. Okay, and then do not consider the circumcircle and from the larger stamping. Okay, no need to extend the line from the middle and then the smallest stamping, just you need to consider the largest stampings. Okay, then you select all these lines, go for mirror by selecting the center of this. Okay, now we will be having an vertical projection on the other side also. So you need to extend all these lines up to the last line. Okay, this is what your last line. So go for extend and the target is this line, enter, and you click on the lines which you want to extend up to that line. Okay, now just I need to trim the unwanted portions here in order to get limb and then winding elevations. Okay, so for that go for Control A and then go for trim. There will be no windings in the yoke, right? So it means we'll be having no windings here. This is the yoke portions actually. Okay, and there will be no windings inside this insulations, so I need to take off. Okay, and no need to show the insulation in the limb also. Okay, now the sectional plan and then elevation of a three-stepped three-phase core type transformer is ready for one lane. It is ready for one lane, but it is a three-phase. Since it is a three-phase, we will be having three limbs. Okay, so I should copy the whole thing. It means select all, Control A, and then here I have a copy and select the center as the base point. This is the base point. Okay, now you need to paste it. So the center to center distance between the limbs is given. It is 42.5 centimeter, right? So it means it is 425 mm. It means at 425 comma 0, right? At 425 comma 0, and I should have one more limb. 425 plus 425, it is 850, right? So at 850 comma 0. So this is what your three phase, but still the magnetic circuit is not closed here. I should close this. For this you join this open sections, you join the limbs, and here you close the window both at the top and then the bottom. Now let me go for Control A and then trim. I will be giving finishing touch for this. Yes. Now you can see this, the central limb, the side limbs. We have three limbs, and these are the windings which are wound on side limbs, and these windings wound on central limb, and these windings which are wound on again the other side limbs. But what's the problem is? The problem is to draw a right of. It means for this transformer, which is the center, I think this is the center for the whole transformer. So let me extend this line up to the last to this line. Okay, so this line will be the center for the transformer. So which is the right one? This is the right of, this is the left of. But in the problem they have specified that we need to draw sectional plan and the elevation of only the right of the transformer, right? So this, it means this is the right of the transformer. So what I want to do is, let me take off these lines. It will be very easy to hatch. Okay, now I need to hatch the winding only for the right off, not for the left off. It means let me go for hatching here. Hatch. Okay, this is what your LV winding in section plan. So let me hatch the same thing, same pattern in the elevation also. This is LV, right? This is the LV and this is LV. This is what your LV winding, and let us go for hatching the HV winding here. Let me select 132, the next pattern, at peak points. This is HV, right? Between HV outer and then HV inner is nothing but HV. Okay, this is the HV winding. Let me use the same pattern in the elevation also. So this is HV, this is HV, and this is HV. And you go for gradient hatching for the insulations. Okay, so now I'm showing every details in the right off, not in the left off. I'm not going to concentrate on the left off. So what I will do, simply I will delete all these elevations. I delete all these elevations, okay, and I will be taking a line and what I will do, I will go for hatch and let me select a different pattern. Okay, so the overall width of the winding is hatched. This is what your right off section plan. Here you are not highlighting the windings in the left off, you are highlighting the windings only in the right off, in the sectional plan also, and as well as in the elevation also. That's why it is called right off sectional plan. So this is the reference, this is the central axis line, this is the right off, and this is the left off. Clear? And now the last stage, it is showing the dimensions, right? So let me show the dimensions. That is center to center distance, it will be 425. And let me show the overall height of the transformer, and then the winding height, window height, it means along with the insulations. Okay, now let us show the dia of all the circles, and this is what your circumcircle. Now let me show the step size also, because we will be having 3 different steps here. So from here to here, this is the bigger step, and then this is the middle one, this is what the smaller one. This is nothing but your 3-phase of sectional elevation of sectional plan of a 3-stepped core transformer. Okay, so do you have any doubts? Clarify it. Thank you.